Great. Let's now move to the second part of this chapter, which is ROS services. We'll start by looking at service messages, then service nodes, manual interactions with those ROS services, and finally, how to create a client server, a client for the service. Okay. Earlier and last week, we saw how publish and subscribe nodes, how the publisher was unaware of the subscriber, and how the subscriber was unaware of the publisher. It only knew the topic. And those messages which were published were sent at unknown intervals. We do have the rates, but there may be some latency going on in the network, and the subscriber may receive all of them or may miss some of them, and it's a best effort communication protocol. Okay? Now, this kind of communication protocol is appropriate for repetitive messages like sensor values, where it doesn't matter if you miss some values. It's simple and flexible. However, sometimes we need a response to every request that we have. We care about a one-to-one reliable communication. And these cases, we want to use a ROS service. This is an on-demand and fast response where the client is unable to do any further work until the service returns the response for the request. Because this is a blocking algorithm, you need to know that if the server computation is too long, then the client will have to wait. For situations in which we have long tasks, sometimes like navigation or manipulation, an action server-client mechanism is better. Okay, so let's jump right in to learning about ROS services, and we'll start with an example service message. The message is the foundation of the service, because here in the message we will define what kind of data we want to send out as a client, and also we define what kind of data do we expect to get back when the server responds. So in effect, the message is what defines the example service. As with standard custom messages, we will need to define the service message inside of a folder called SRV, and those files will take an extension .srv. We'll see that service messages have two sections, a request and a response, and that these sections are separated by a 3- line in this way. Okay, just to show you on the system, let's open the terminal and ROS-cd to example ROS service. And so here is the SRV folder. And here we have some examples of SRV files. We can use less to quickly see that. And you can see that the top part here is the request. That's what the client will send to the service server. So here, for example, we're going to introduce a little example where you send the name of a person, and the service kind of looks into a very simple database, and it's looking at whether or not this name is on the list, so this can be true or false. And it's going to determine whether that person is good or bad, and return the age of that person and then the nickname of that person. So you can see that for the response, we actually have 4 things that we want to fill out and be able to return. As with custom messages, we'll need to, if we want to use this particular this particular service, we need to include that package and the package XML as a dependency, and we may need to add some things to the cmakeLists.txt. If we're using Catkin Simple, we don't need to add extra information, as this is taken care of under the hood. Okay, so this are the dependencies for the package XML along with the package for the service. And currently we have this # here commenting out the nodes, but by simply running catkin make on this Catkin Simple version of the cmakeLists.txt, we should be able to create our service definition. Okay, where can we find that? We go to the top of our workspace, go into the development folder, go into the include portion, and then look at the package name, example raw service. And what you'll notice here is that instead of simply having one header file, now we have 6 header files. Oh, sorry, 3 header files for example service. One is simply the request, the definition of the request, a definition of the response, and then this macro header file, which includes the definitions of the other 2. Okay, this is explained here. And this, then we can analyze the kinds of service messages that exist in our service, in our system, using the ROS service command. This is similar to the ROS message command, and it can show us all the existing ROS services in our system, what they look like, and a list of them. Now, notice that this is a little bit different from this command, the long version of ROS service, which in turn is used to examine running service nodes. So for now, we can just say ROS service list or ROS service show along with the package name and the name of the service. Sorry. So let's do that. You see that we have all these possibilities. For the list, we have many things that we can run, including the example ROS service message. So if I say show, raw service show, and paste this, then we get exactly what we included in our .srv custom file. All right, great. And as before, if we want to use this service message in our code, we'll need to include it as a header as indicated on the screen. Okay, so in later part of this section, we will create both the service server and the client, but we will first begin with the service. Okay, make sure that your cmakeLists.txt file has this line uncommented. This will be the example raw service, which implements this CPP file. Now, as before, all of these CPPs are very simple. We define the headers. Now here we're going to have a callback, the callback prototype that has the request and the response types. We'll see how that works. We'll process the request and provide a response. And then in the main part of the code, we'll create the service object and we'll advertise a service, including a ROS spin. So let's take a look at that. We can use ROSED. The package is example raw service. And then here we can look at example raw service.cpp. If you wonder how to copy and paste from a terminal, you cannot use Control-C. You need to use Control-Shift-C and Control-Shift-V. Okay? Let's maximize the window. And we start with our headers, ROS header, and then service message header. Remember, this is the foundation, as it defines exactly what the service will do. And then third-party libraries are here. Let's go down and start with the main function as a place to start. We initialize the node, we have a node handle, and then the next thing we want to do is create the service. So the first part of this is using the ROS service server type, which is similar to the ROS publisher or the ROS subscriber. Okay, so here you got to use the keyword service server. We create our object and then use the node handle to advertise. In this case, it's not a topic anymore, but a service. And as with a publishing object, the first thing that we need to do is provide a topic, but this is not going to be a normal topic, this is going to be a service topic. And any time we want to look up this service, we will do so by using this name right here, lookup by name. Okay? And we also include the name of a callback function here, because the service server, of course, will be like a subscription object. We'll need to call a callback to service the request. Okay, so the callback name goes here, which is defined on the top portion of our code. We'll come back to that in a second. Then you can include an informative message, ROS info, to tell the user that the actual service server is running. And we must call spin in order to process all the requests in the callback. Great. So let's move over here to the callback and look at the argument list. Number one thing to notice is that we have two arguments, the request and the response. And the types of both of those come from our package name and the name of our service message. So the package name is example raw service, and then the root part of our service message is example service message. Then ROS does some work behind the scenes to append or add this extra name here, or extra name to the type for both the request and the response. This is done completely automatically, and this is something you need to know in order to appropriately code your argument list here. Request and response are arbitrary, but are useful names to define what they're going to do. Okay, so we start here by printing out a message saying, hey, the callback is activated. Okay, from the request, we have one thing that is sent out there. Remember what that is? So if we open a new terminal and type raw service show, example raw service, example service message, this is our request. We have a string we call name. So right here from request, we are able to access that element name, which is a type string. So what we're doing here is creating an object called inName or input name, and it's going to be an object of this class. This string request.name is being passed into the constructor. Okay, and so now inName will give us access to many methods of the string class. At the same time, then we can access the response variable and modify it according to a logic that we implement. Here, what we're going to do is we're going to have two comparisons using if this name is Bob or if this name is Ted. So here we first initialize it to false. Then we say, hey, if the incoming name is Bob, compare as a method in the string class, and if they're the same or equals 0, then let's print the following response. Hey, you are asking about Bob, and his age is 32 years old. He's not a good guy. Yes, he's on the list, and his nickname is Bob the Terrible. On the other hand, if the name is Ted, we can say he's 21, he's a good guy, yes, he's on the list, and he's Ted the Benevolent. And otherwise, we don't print anything. We just return true. Great. So this is an example of a service server. Remember here, we need to advertise the server, include a callback, call spin, and then be able to manage requests and response in a way that is consistent with our logic. Okay, so remember to cat can make if you haven't already done that, and once we have the service executable, we can run it with Rust run. Okay, so in this case, let's go back here, make sure you have Rust core running. Okay, and here we can run the example raw service. And here we see that it's ready to run. It says ready to look up names. Okay. And we can analyze the existence of this service by using the command word raw service. This is the longer version. Like this, and look at this interesting list. How is this service described? It's described by the topic service name that we advertised in our code, lookup by name. The other raw services are running behind the scenes. This is ROS out services that do some logging information, and these are other logging services that run behind the scenes for every node out there. Okay? And we can currently make a manual client request just from the terminal. Anytime that you have a service server running and you want to call it, we can use the call function on raw service, followed by the service topic name, and then providing whatever number of arguments you need to fill out your request. So if you only have one element in your request, like in our cases, a string called name, here we can just provide one single argument. If we had two, they would follow in right order, and you'd need a space between them as you fill out the arguments. Okay? So if we wanted to make a call to the running service server, we can say raw service call, lookup by name. You can tab on that and then type a string name like Bob. So when that happens, we get the reply. The service server has this ROS info, asked about some name, but then it returns all these things on the response. Is it on the list? Yes. Is it a good guy? No. Age 32 and nickname Bob the Terrible. Of course, most of the time we will not be calling service servers manually. We want to do it using C++ code or Python code. So now we will look at an example for a ROS client. Okay, this is called example ROS client.cpp. And the structure of this code will include ROS headers. And then here we need to create the client object. We need to create the service message object and then fill out that service message, call the server, and get the response. So this is very interesting because you are getting information back on the client as well. It doesn't just stay on the server. So we'll call the server with our request and then we'll get a response. Let's take a look at that code. I'll maximize this window, clear it, use raw set, example raw service, example ROS client.cpp. Maximize the window. Okay, so here's ROS.h. Then we, of course, need to include the service message header file because it's what defines how the service works. Third-party libraries, main function. Initialize the node. This is going to be the name of the node, example ROS client. We have the handle, and now we're going to create not a service server, but a service client object. So here's our object, and in the service client, there's a few things we need to include. Number one, the type of the service. Again, this is the package name, example raw service, and this is the type of the service message. Then we include the service topic right here. This is all that we need in order to provide enough information for the service client to connect to the service server. The next thing we need to do is instantiate a service message that will be useful to fill out the response and the request. Okay, now for this client, we'll have some interaction with the user on the terminal. So here basically what we're going to do is we're going to cin some names. We create a found on list variable, set it to false. We create this empty string called inName, and then we'll run this on a while loop, and we'll say, please enter any name. It will be a string or X to quit. And so anything that you enter into the terminal will be directly saved into the string object. Quickly, we compare to X. If so, we return and exit. Otherwise, we say that the service request name will be set equal to this string and name. So we might be inputting Ted or Bob or Joe or any such name. Okay, this is a copy constructor here since both of these are strings. And then once we have that request information, what we want to do is call the service server. The way to do that is by calling this method call from the service client and pass the service message in it. So this is something you will do very often in your service call, and it should be included inside the if statement logical argument, such that if this client call is successful, you can run a particular set of code. Otherwise, you can return a ROS error and declare that the call has failed. Okay. And then this logic right here is just for the example at hand. But notice that this service element is now going to be able to access the actual response from the server. So when the client call returns, all the response fields have been filled by the service server. So this on the list will either be true or false. So if it's Bob or Ted, we will go into this if conditional. Okay? And so then here we can say, hey, for this name, whatever it is, Bob or Ted, we can get their nickname from the response element. So very interesting. Here we can work with the request, but we can also get the answers now from the response. And we can get the age from the response element and whether or not he's a good guy. Okay? So this is how it runs. And cat can make and make sure everything's okay. And once you do that, you can run the ROS service and ROS client nodes. You can issue them in different order to see how they may respond. Okay, here we have ROS core running. Here we have the ROS service from before. Okay, and so here we could just run the client. Example ROS service, example ROS client. Here it's asking us to write a name, so I'll write Ted. We see that the callback has been activated on the service server side. We know it asked about Ted. And then all those responses are coming back. And this was the request name. This is the response nickname. This is the response age. And this is using the response good or bad guy. It's running in a while loop, so we could do this again with Bob, and we see the same results. If we type Joe, we just simply say this person is not in the database, or X to quit, and Control C to exit the server. Okay, fantastic. Some things to pay attention to for the ROS message service. Did you know that while the client node is active, it can send repeated requests? We just did that by typing names back and forth. Did you know that other client nodes can use the service as well? So you could have 2 independent or 3 independent client nodes that are requesting things from the server. Those clients can run at the same time, and the server returns a unique response to each of those clients. In a robotic example, this might be useful to tell the robot, say, to open a hand or close a hand, or it might be to say to a force controller, hey, this is the desired force that I want to see in the robot, or similar cases. You will normally have to create your own service message that is very specialized to your needs, and you can use this for very fast request-response interactions, not for slow ones.